Hey, today we're going to talk a little bit more in detail about the electron configuration, but we're also going to talk about how that relates to the Lewis structure for an atom. So, what I told you before is looking at your electron configuration is there are these orbitals. This is basically one quarter of the diagram of an atom. This is the nucleus with the protons and the neutrons. This is the first orbital, second, third, and fourth quantum level. 1, 2, 3, 4. But nothing is never this easy in chemistry. It's a lot more complicated than this. Each one of these orbitals is made up of one or more suborbitals. So this is a very simplified way of drawing it. But in actuality, the orbitals have a lot different shapes. And it's based on where an element is in the periodic table. Now you look at the electron configuration, remember that's the number on the bottom left, and the electron configuration tells you exactly where they are in this format. But in actuality, the orbitals are a lot more complicated, and this is something that you will learn in college chemistry. But just to summarize, we have our very first orbital. So first of all, let's talk about something like sodium. Actually, we'll use magnesium. Magnesium's electron configuration is 2, 8, 2. Again, 2, I don't know if you're going to see that, 8, 2, which means 2 electrons in the first orbital, 8 in the second orbital, and 2 in the outer orbital. And this outer orbital has a special name. I'll tell you in a second. So basically, when we look at this, the first orbital has a spherical shape. The first two electrons are found here. Now these next 8 electrons are found in one of 4 different suborbitals. So this is where the first 2 are found. And then if you imagine this orbital is inside this orbital. So I'm just going to, there, I put them all inside here, okay? So now I have 2 on the white balloon on the inside, and then I have 2 more in the next balloon outside. Now I have 6 more electrons that are not taken into consideration. So I'm going to take these 4 electrons and shove them inside the middle of here. So now I have 2 in the white balloon, 2 in the pink balloon, and now I have 2 electrons floating around the blue balloon this way, really fast, 2 electrons floating around the red balloon this way, and 2 electrons floating around the yellow balloon this way. So that's 2 white, 2 pink, plus 6 around these 3 colors. That makes 10 total electrons. And then if I imagine that all of these electrons are in another orbital that is a round orbital around everything, where I have 2 more electrons. And these 2 electrons are really the only thing that we care about. They are called the valence electrons. The valence is just the outermost electrons in an atom. And the valence electrons actually determine the activity of an atom. If you have a low number of valence electrons, you want to get rid of them. If you have a high number of valence electrons, you want to add to them. We want to get to a magic number in chemistry. And that magic number is not a 2, but it is an 8. We always want to have 8 valence electrons. And that is called an octet. An octet just means it has a fully satisfied valence. What does that mean? That means the maximum number you can have in the outer shell is always 8. You cannot have any more in the outer shell. Never, ever, 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 ever. Only 8. These elements that have 8 valence electrons are always satisfied and they do not react. One other thing about these valence electrons is you can use them to show an electron dot diagram. So for example, I'm going to look at oxygen. And oxygen is atomic number 8. It's right here on the periodic table. And this is how it is written. The 16 goes on top because that's the atomic mass. The 8 goes on the bottom because that is the atomic number. The oxygen, the O is the symbol. Now if I look at the electron configuration, it is 2-6. Now when I draw an electron dot diagram of this, I'm going to write the symbol, which is O, and then I'm going to draw 6 dots around it. And I'm going to start on the left, and I'm going to go clockwise. 1, 2, 3, 4, 5, 6. That is how I draw it. That's oxygen. Let's try another one. Let's try chlorine. Okay, chlorine is atomic number of 17. There are 35, that is the atomic mass. We're going to look at the valence electrons, and we have 7 valence electrons. So it's Cl, and again, start on the left. 1, 2, 3, 4, 5, 6, 7. Notice, these dots form a box. We do not go out like this. We go side by side. Okay, maximum of 8. So chlorine has 7, it needs 1 more. Oxygen has 6, it needs 2 more. If I did something like lithium, which is atomic number of 3 and the mass is 7. So mass goes on top, 3, it's Li. When I draw the electron dot diagram, I'm going to look and see that there is only 1 valence electron, so it gets 1 dot. So this is how I show electron dot diagrams for these elements. Practice.